there are a lot of applications that involve, and I'll let you choose, a lot of applications that involve quadratic functions. Here is a one, the path of a ball. Okay, throwing a ball. The quarterback. Revenue, when the quadratic function is given to us. Sales, quadratic function is given to us. Advertising, quadratic function is given to us. Pharmaceuticals, quadratic function is given to us. Agriculture, fencing, making a rain gutter, and I can go on forever. So please make a decision. Any interests? Which one? Sales. Fine. So problem 66. Yes.
Did you rearrange the order of the terms?
So remember, factor simplify. Factor simplify. You do whatever you need to make it easier for you.
Okay.
If you, for example, give me a quadratic equation that has a negative leading coefficient, I can do whatever I want.
Okay.
As long as I'm giving you the solutions, I'll clean it up by removing the negative leading coefficient, I'll factor, I'll whatever. And I'll show my work and give you the answer.
Okay.
So in sales, so number 66 on page 231. And a soft drink vendor at a popular beach analyzes his sales records and finds that if he sells X cans of soda pop in one day, X, when I read, I take notes. Number of cans sold. His profit in dollars, P, profit in dollars, is P of X negative 0.001 X squared plus 3X minus 1800. If this is not arranged in descending order, I will not be able to I may not be able to correctly identify the leading coefficient, the middle term, and the middle coefficient and the last. Okay, so the question is, what is the maximum profit per day? And how many cans must he sell for a maximum profit? This type of problem is also part of a big field in mathematics called optimization. And optimization is huge. It's absolutely huge. Bigger than, I think, algebra and calculus put together. So, because it uses both. So, I'm asked to find the maximum or the minimum. What type of function is it? That's my first question. So, all those questions that I'm asking you because this is the way that it leads, the path that leads to your thinking and ultimately solution. So my first question is, what is it? Yes. Second question, is it in descending order?
Yes.
Good. Third question, what am I asked to find?
Max.
Right. Does this function have a maximum? That's my next question to myself. Does it have a maximum? Why? Because the leading coefficient is negative. Okay, now my final question is, how do I find the maximum of a quadratic function?
Vertex.
Right. So what do I have to find first in order to find the coordinates of the vertex? Right. So negative. B is 3. 2 times A, negative 0.002. Very good. Then, here's what I would do. I would not even plug this in a calculator because I have to multiply top and bottom. There, of course, it has to be positive. I cannot sell a number of negative cans, right?
Yeah.
So negative and negative will be positive. So I change 3,000 divided by 2. It must be 1,500. The measurement unit is crucial. What is it?
Dollars.
Very good. So I know that this vendor has to sell 1,500 cans per day in order to make his maximum profit. But now the question is, what is the maximum profit?
Right. So then you have to have 1,500.
Exactly. It doesn't matter. It's the same thing. And that will have the measurement unit what?
dollars.
Yes. So please give me the answer. $4,950. Can anyone confirm? I don't have the answer. I mean, I can plug it in. Okay, I'm going to. I had to go to the task manager and kill this because
2697.75.
What? No way, I did it 3 times.
Maybe
Oh, it's negative.
okay, I think I'm gonna be able to do it now because I had to kill the application.
Oh, I got 450, yeah. I got 450. It's negative.
So negative 0.001 multiplied by 1500 squared, and then what is it? Plus 3 times that's 4500, and then minus 1800. 450?
Yeah, I forgot
Okay.
the negative sign.
That's okay. So then I correct that. I did to 450. So this is 450. So what would you say to this vendor? Sir, ma'am, if you want to get a profit of $450 per day, make sure that you sell 1,500. Okay, so let's take a look at the following function.
It's a different question.
A different function, I want to graph it, yes. Number 1, what is the shape? Maximum or minimum? Yes, I completely agree. This is the leading coefficient. A equals -1, so it's a maximum. Question number 2, I want you to give me the vertex. I want you to picture the graph slowly, carefully, and not do anything else, but just give me the graph, the vertex.
-0.4.
Very good. Do we all agree with -1, 4?
How do I get that?
Here it is. X squared, 1 to your left.
Oh, it's expressed.
Okay, so that is the form. So if I'm given something like this, oops, I meant a here, x minus h, everything squared, plus k, the vertex has the coordinates h comma k. Is that clear?
Yes.
Okay, but keep in mind this negative, but we already know what happens to x plus 1. When I change x into x plus 1, I go to the left 1. Good. Okay, number 3, x-intercepts. Does this function have x-intercepts? Very good. Why? Because the maximum is
Above the x-axis.
above the x-axis. Can anyone give us the range? We haven't even graphed it. But can you picture the range and give me the range?
4 to -8.
Yes, but we have to start from below. You're right.
Or -8.
Negative infinity to 4. Is that clear? Okay, very good. So the x-intercepts exist. So how do I find them again? What do I have to set?
Set y to 0.
Very good. I have to set y equal to 0. which is negative x plus 1 squared plus 4 equals 0. How do I proceed?
I would say 4.
You have to say that, because you want to make me happy.
Divided by the -1.
Right.
And
Yes?
then
Awesome. How many solutions do I have to write, because I don't want to forget something crucial? I ask myself, I'm solving a quadratic equation. How many solutions do I have to find?
2.
Very good. So the left-hand side should be the absolute value of x plus 1. Instead is x plus 1, but the right-hand side, okay, one more time. How many solutions do I have to obtain?
2.
2. If I only write 2, where will the second one come from?
Plus or minus 2.
Ah. That's why I asked how many solutions, so we don't miss this. So x equals -1 plus or minus 2. Can anyone give us the 2 solutions, please?
3
Careful. -1 plus 2, -1 minus 2.
Oh, 2 of them. That's it.
1 and -3.
Yes. So what are the solutions then?
1, 0,
1, 0, -3, 0.
Very good. Number 4. Y-intercepts. I'm sorry, Y-intercept.
X.
Yes, I have to find f of 0. Let's do this together. 0 plus 1. 1 squared. 1 times -1. -1 plus 4. Good. So the ordered pair is?
0.
Okay, 5 and 6 and 7. You already gave me the range. You said -infinity to, what was it, 4, right? Yes. Good. Axis of symmetry, please. What is the axis of symmetry? I'm not talking about odd and even functions. I'm talking about the axis of symmetry characteristic to any parabola.
-1.
X equals -1. Axis of symmetry. What did we say this function had, max or min?
Maximum.
So max is, for this function, and the maximum value is always the y.
4.
Maximum is 4. So let's graph it. I start with the vertex, which was -1, 4. I continue with the axis of symmetry, which only helps me to keep the graph in shape, -1. I continue with the x-intercept, 1, 0, and let me just make a point here. If the solutions were 1 and -5, would you have thought, oops, something is wrong?
Yeah, your symmetry line would be off.
Exactly. Because all the points have to be symmetric, right? So if this is 2 units away from -1, this cannot be 4 units away from -1 on the other side. Clear? Good. And 0, 3. So this is, I want to add something here, and here's my question. I would like to ask you, where is this function increasing and where is this function decreasing?
From -1 to the vertex. Why is it?
So remember, the increasing and decreasing intervals refer to x only. We're not interested from what value to what value is increasing or decreasing from what to what. No. We're asked to determine on which x interval the function has the increasing trend. on which x interval of the function has a decreasing trend. One more time. Where is this function increasing? Where is this function decreasing? That's it. Perfect. Okay, moving on to polynomial functions. And you can say, but what was this? Wasn't this polynomial? Yes, it was. But normally when we talk about polynomial, functions, we mean degree 3, 4, 5, 6, and so on and so forth. But you're right. If you had said, but the linear function is polynomial, I would have said yes. But quadratic function is polynomial, I would have said yes. But now we are looking at higher degree polynomial functions. 3.2, cubic, 4th degree, 5th degree, 6th degree, and so on and so forth, polynomial functions. I have to say this. If you understand the cubic function and the 4th degree function, you will have absolutely no secrets ever in polynomials. You will have absolutely no problem. There is one thing that we cannot determine in this section, and you will be able to determine in the next class with no calculator, is the max-min. Not vertex. That word is reserved for quadratic functions only. So when we talk about polynomial functions, we will degree 3, 4, 5, 6. We will not talk about vertex. Vertex is done. If it's not quadratic, there is no vertex. Okay? Good. So I'm going to illustrate with a cubic and then a 4th degree, and then we'll work on other higher degree. Let's choose a function. They are on page, it's a lot. So the first example will probably take 20 minutes. The next one will take 3, and the next one will take 2, and the next one will be like this. But the first one, I have a lot to explain. Okay, we are on page 244. I'm looking at problems 15 through 40. Bless you. So 15 through 40 on page 244. Can anyone choose a cubic function for us?
$17.
17. It is cubic. (17) f of x equals x times x minus 3 times x plus 2. Perfect. Remember when we just graphed the quadratic function, I dragged you through 7 steps, right? Now I have to drag you through several steps as well. The first one, and you can say, but you didn't put this one in quadratic. True, I didn't. I should have, but since we know that polynomial functions are defined everywhere, I skipped that. But now, from now on, I have to put it, because from higher degree, it's not it's going to change, but then we get to rational functions, and I don't want to forget that, for you to understand how important it is. What is the domain of this function? Yes, all polynomial functions are friendly functions. I call them friendly. They are defined everywhere. Yes, very good. Number 2. X-intercepts. I want to refresh your memory on 2 things. After we talked about the X, let's talk about the X-intercept first, and then I'm going to edit it. So, what is the degree of this function?
3.
How many solutions? 3. Yes. So I expect 3 zeros. However, some may not be real. When I say some may not be real, it means that I may find 3 solutions. I have to find 3 solutions, but maybe some of them will not exist, and the function will not cross the x-axis 3 times. It's possible, but I will find 3 solutions. Okay, how do I find the x-intercepts? Right. So I have x, x minus 3, x plus 2, and our thanks go to Paul for picking a problem, a polynomial function that is already factored for us. Thank you. We will allow him to pick some other time. Yes. Very good. Here's my next question. How many times, that's my step 3. How many times does x equals 0 appear as a 0 or as a solution of the equation y equals 0? How many times does it appear? Once. I will say x equals 0 has multiplicity 1. The word multiplicity, one more time, means how many times does this solution appear in the equation when I solve the equation y equals 0. What can you say about x equals 3? What is the multiplicity of 3? Yes. What can you say about x equals negative 2? What is the multiplicity of x equals negative 2? Yes, same thing. Okay. What does that mean? So what? Why isn't this even important? Knowing the multiplicity of the zeros. So item number 3 is multiplicities of the x-intercepts or zeros. Which one would you like me to write? It's the same thing. Of the x-intercepts. So I'm going to make a parenthesis here. That's why it takes 20 minutes to half an hour, the first example. Because I have to go through all possibilities, like we did with the quadratic function, the first one. Okay, I'm making a parenthesis here. Here are possibilities for odd multiplicities. What does odd multiplicity mean? A solution appears, right? So an odd multiplicity would be when a solution or an x-intercept appears once, 3 times, 5 times, 7 times. Okay. Here are the possibilities for multiplicity 1. What is the possibility for multiplicity 1? So M multiplicity is 1. I'm moving on to multiplicity 3. Multiplicity 3 looks like this. And I would like you to give me an example, because we looked at this function. It doesn't mean that there are 3 solutions there. Right? It's the same solution 3 times. So this is one solution once. Exactly. This has 3 solutions there. Not 3 different solutions. The same. So this is multiplicity 3. It takes its time if you want to remember it like this. It takes a while. Goes through smaller and smaller values and finally crosses, and then smaller and smaller and bigger, bigger, bigger. Okay? Here's multiplicity 5. Of course, it can come from above. It doesn't have to come from below, right? The x-axis. It can come from above, but it's the same thing. So here will be multiplicity 5. And it takes its time, and it takes its time, and it takes its time, and yes, yes, yes. Oh, finally crosses it. Ah. So see the difference? Fast, slow, Very slow. What if I have multiplicity 7? What will happen? Even slower. Okay. Now here's what happens with even multiplicity. Here it is. What is the first one? Multiplicity? Right. How does that look? It's a turn. Yes. It's a turn. How many solutions are here? What is the multiplicity? Now, do you remember when we talked about this case? What did I say here? Right, that's why it's a turn. What do you think is going to happen if the solution has multiplicity 4? Exactly, the same idea, but the turn. Slow, but the turn. So here it is. Okay, it takes its time, it gets closer, it gets closer, it gets closer, it gets closer. Okay, finally it touched. And then slowly, slowly moves away. And you can say, what's such a big deal? The graph will be totally different. So you see, this is one thing and this is a different situation. Okay, so coming back to our problem and multiplicity 1, which of 1, 2, 3, 4, 5 will be the case for x equals 0, of course 0, 0, 3, 0, and negative 2, 0. Which one will be the case? 1, 2, 3, 4, 5. Of course. Multiplicity 1 is just a straight cross. Very good. Okay, number 4. Moving on to number 4. Y-intercept. I said, right, so I have to find f of 0. Let's do this together. Once I have x equals 0, y equals 0, this is the same point. I cannot have, a function cannot have two y-intercepts. Okay, 0 minus 3 is negative 3. Negative 3, 0 plus 2 is 2. This is negative 6, but multiplied by 0 will be 0. So, of course, once I have x equals 0, that is, yes, that is the y-intercept as well. 5. Something we have not discussed before because there was no need. But now there is a huge need. And behavior. We did apply it. I didn't tell you what it was. But we applied it many times so far. Okay. How does a linear function look like?
Straight line.
This is one case, and this is the other.
Yeah.
Okay. So I'm going to make a little chart. You know me already. Odd degree, even degree. It's because I need to summarize everything. And it will be also easier for you to look at what we're trying to do. So I'll give me an example of a function of odd degree, the simplest possible function of odd degree. Right. So it looks like this, or it looks like this. Give me the simplest possible function that has even degree. Right. So it's either this or this. Correct? Good. So what is the end behavior? Now we are sophisticated. What is the end behavior of this function? From negative infinity to? Right. What is the end behavior of this function? From, it's always from left to right. From to negative. What is the end behavior of this one? Back to positive infinity, yes, because it's an even degree. It goes back where it came from. But what about this one? Right. Now here's what I'm going to do. I'm going to delete the middle. And that is the end behavior for any odd degree and for any even degree, no matter what function. So if it's cubic, it will have this or this. If it's fourth degree, it will have this or this end behavior. If it's fifth degree, it will have this or this end behavior. If it's sixth degree, it will have this or this. What is it depending on? What was it depending on here? What did it depend if it's this or this?
From the X
Which one?
coefficient.
That's it. What was it depending on here? So it's the same for any other function. If it's degree fifth and it has a positive leading coefficient, it's this. If it's degree 8 and it has a negative leading coefficient, it's this. Always go back to the basic functions of linear and quadratic. Now I want to show you, because it's difficult in writing, let me just show you how many pages are in the book on this little chart that I created there for you. Okay? Okay, it starts here. There's no need for this, but it's difficult to put in writing. Look. 1, 2, 3, 4, 5 pages. On this. I'm not saying it's wrong. I'm just saying it's very difficult to explain in writing and put it in writing. So it's a lot of writing. If you remember, Nico, we looked at, what is this? I couldn't even read it, right? Because it's difficult to put in, sometimes math, different topics. Okay, so I'm back to my function. What do I have to identify then? To find the end behavior? Right, exactly. So what is the leading coefficient of this polynomial?
It's positive.
Right. What is the degree again?
3.
Okay, which is it 1, 2, 3, or 4? Exactly. So what would be the end behavior if it's 1? I don't care what it does in the middle, but what is the end behavior? From, that's it. So I will start a chart in a minute. You'll see why. And I'll show you examples in the book and you'll see what I'm talking about. Okay, so in my chart, I start with the domain. I'm coming back. I'm not done with those items. But I want to summarize now what we have. So from the beginning, you told me the domain, right? I put it in the chart like we always do. Negative infinity to infinity. Then you gave me the X-intercepts, right? You said the degree is 3. I have to find 3 zeros. And I found negative 2, 0, and 3. What do I write for the function value under these specific 3 x values?
0.
Of course, they are the X-intercepts. Then I write myself a note. You write whatever you want. I'm going to write simple cross or straight cross or use whatever you want to use. It's just a reminder for me. So I don't forget it's a straight cross. There is no wiggling room there. Simple cross. Simple cross. Why?
Wait, what does that mean?
Simple cross means just the way. Okay.
Because the multiplicity for all these 3 is? Okay, so I'm back here. So I know, as you mentioned before, you already told me it's going to be this. Now I want the y-intercept. It's already in there. Finally, I want the end behavior. One more time, what is the end behavior? Negative infinity to positive infinity. Number 6. Maximum possible number of turns. Don't say anything, please. Let's analyze and we'll talk about it in a second. So, linear function, what is its degree?
1 point.
What are the maximum possible number of turns?
None.
Right, degree minus 1. How many turns does the x squared have?
2.
Degree minus 1. How many possible turns can a cubic function have?
2.
Not more than 2. It doesn't have to have any, but it cannot have more than 2. Do we know a function that is cubic, but it doesn't, or we expected 2 turns, but it doesn't have any? By turn, I mean max or min. That's what I mean by turn, right? This is x cubed. Well, it's shifted, but if it were right here in the middle, or the x-axis, or the origin, what is the degree? How many max number of turns can it have?
2.
How many does it have? None. It doesn't turn. It goes up all the time. So when I say the maximum possible, this is the key word. Possible number of turns is degree minus 1. But it doesn't have to have any.
Turn is if you change from increasing to decreasing or back.
Exactly. Yes. Turn means it changes from increasing to decreasing or from decreasing to increasing. Or it has a max or a min. Not vertex anymore. Okay. Very good. So what is the maximum possible number of turns for this specific function? Careful. What was the degree? 3. 3 minus 1 is 2. Number 7. Is there more? No. That's it. Max, min, not vertex anymore, with TI. We can't do this without the calculator. Okay. The key in order to understand these functions forever is not grab the calculator. I haven't graphed this. Paul just picked it, right?
Yes.
Not to grab the calculator and look at the graph yet. No, we need to understand what's happening. And here's how what is my take on it. The function, follow my hand for a moment. The function is coming from negative infinity. Obviously, it crosses the x-axis at negative 2, 0. Well, in order for it to cross again at 0, 0, it must have a turn or a maximum, yes, right? Then it crosses at 0, 0, but then it has to come back and cross at 3, 0. It must have a, right, it crosses at 3, 0, the x-axis, and goes to infinity. I'm done. I already have the picture in my head, right? From this chart. Not from writing 3 pages, because I can't summarize it. I will not even know where to look. Look how easy I think, if we get used to it, it is. From negative infinity, it's increasing towards the x-axis at negative 2, 0. But it has to turn, because it has to come back and cross at 0, 0. It continues to decrease. It has to turn, because it comes back and crosses at 3, 0 and goes to infinity. I have the graph. So I'll graph it. I start with the x-intercepts. Here they are at negative 2, 0, at 0, 0, and at 3, 0. They're all straight crosses, nothing fancy. So it's coming right here. Look, it's coming from negative infinity, goes up. Here, this one doesn't make any sense. There must be a turn here. Between this point and this point, there must be a turn. And between this point and this point, must be a turn. I'll figure it out in a minute with a calculator. So here it is. It's coming from negative infinity. It must turn because it crosses at 0, 0. It must turn because it crosses at 3, 0. And according to the end behavior, it has to come from negative infinity and go to positive infinity. Yes, without calculus, I will not be able to determine this max. It's a local max. And determine this min. It's a local min. I will not be able to. So that's the last step. And I will put them in my chart. And there is no secret anymore about this function. We know everything about it. But I have step 7. I have to do it with a graphing calculator. Let's see if this cooperates now. Okay. Oh, actually, thank you. So we have x, parentheses. It was x plus 2, right? Parentheses, and then x minus 3.
Does it matter if it's X?
No, it's the same thing. 2 times 3 times 4 is 4 times 2 times 3, and so on and so forth. Okay, so let me see where I'm with this. Okay, 41. Okay, so let's go to the viewing window. It's standard. It went back to standard. That's fine. So let's graph. As expected, it's coming from negative infinity, crosses at negative 2, 0, coming to a maximum, have to turn and cross at 0, 0, have to turn again because it crosses at 3, 0 and goes to infinity. Before the class today, you didn't expect that you would be able to graph something like this and picture it, right? So now when you punch in the calculator something like this, you will not be surprised. Oh, I know. Degree 3 cannot have more than 2 turns. Degree 3, positive leading coefficient, has to have the same end behavior with a linear function with a positive leading coefficient. So now let's determine the max. The max is between negative 2 and 0 with second and calc. I want 4. So negative 2, enter, 0, enter. I don't want to guess. Just give me the answer. It's negative 1.1, negative 4.1. Negative 1.1, negative 4.1. I already put it in my chart. And now I want a minimum, and I see it's between 0 and 3. Second and calc. 0, enter. I'm sorry. Second and calc. I want the minimum, which is 3. So I made another error. Okay, so I want a minimum, which is 3. For some reason I pressed the enter. Yes. So I want 0 and 3. And give me the minimum. I don't want to guess. So it's 1.8 comma negative 8.2. 1.8 comma negative 8.2. So now I know absolutely everything about this function. I know this as being negative 1.1 comma negative 4.1. And I know this as being 1.8 comma negative 8.2. In the next class, we are going to be able to determine this by hand. Any questions?
Why is it a negative 4.1? Could it be positive?
I put negative in there? No, I don't know. Sorry. Of course. Thank you, thank you, thank you. Yes, of course. Thank you.